Kiddies, 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 welcome back. Section 4 of Chapter 5. Get ready, prepare yourselves mentally today, kiddies, because today we are doing one of the more important things that we will do this entire year, something that you'll need to know and something we'll be using for the rest of the year. So you got to make sure that today you really take good notes, pay attention, write down any questions. One thing you're again going to really have to know when you do this is the idea of slope and rate of change that we talked about in 5.3. So if you have any questions on that or a little confusion or whatever it may be, make sure you clear it up before we jump into this lesson. So if you're ready to go, let's get ready to go ourselves. All right, dorks, why the heck did I show you that? That's a little Rocky 4. What a great way to get yourself motivated, especially motivated, to do some math. Heck yeah. Here we go, let's get started. So today what we're going to talk about, kiddies, is what's called Slope-Intercept Form. I think it was last lesson, we looked at something called standard form of linear functions, and we graphed those using what's called an intercept. That was section 2. And now we're talking about slope-intercept form. So it's another way to represent a linear function. And this is probably the one we will use most often. And as I said, this is going to be something that's very important for us for the rest of the year. So what is slope-intercept form? Well, slope-intercept form is just an equation on how we write a linear function, but it includes two things. It includes what's called the slope, which we learned about in 5.3, and something called an intercept, which we learned in 5.2. So notice how it's combining those two ideas. I like to think of this as the ingredients. Okay, slope-intercept form, what two things does it include? Well, it includes the slope and it includes the intercept. Ooh, a little update to this app. I can now highlight things. Pretty neat, huh? So two things we're talking about is slope. So we'll just kind of quickly review. Remember, slope is what we talked about in 5.3. So if you're confused at what slope is, make sure you go ahead and take a look at that section. So slope, rate of change, this talks about basically the same thing. Slope and rate of change are interchangeable. They mean the same thing, just obviously said differently. Slope and rate of change, what does it mean? Well, slope is simply how the x variable changes in relation to the y variable. Okay, we talked about that slope represents what's called the rise over the run. It describes how much the line goes up as compared to how much it goes right. And then between any 2 points, again, we represent that slope as the rise over run. If you think of rise, the way I like to think about rise is it looks at your change, and this little triangle symbol here, little triangle symbol means change in. So it describes your change in your y divided by your change in your x. Now, we symbolize slope with m, and I gave you guys the formula last video or last lesson that change in means you take y2 minus y1 and divide it by x2 minus x1. So you get your rise over your run. Now, slope, that's going to, again, describe the slant or the steepness or the angle of that line. The y-intercept, we talked about this before. The y-intercept, as I introduced, is the point where the line crosses the y-axis. The way I want you to visualize this is right here, our first bullet point, which at the y-intercept really represents the starting point, or the initial value. Something I introduced to you way back in section 1. But this is going to make it a lot easier for us to graph when we understand the y-intercept as our initial value. Okay, and then some other definitions again. Yeah, it's where the line crosses the y-axis, but remember that the y-intercept is the value of y when your x is 0. So this is another important thing. It is when your x-coordinate is 0. Something to always remember there. So these are the two ideas we're going to need to understand in order to graph using what's called slope-intercept form. Okay, so notice last thing in this equation, you have the two things written. You have y equals mx plus b. So right here in this formula, the slope, remember our symbol is m, and then our symbol we're going to use for the y-intercept is going to be a lowercase b. Now I'm not making this up. This is something that anybody that does math or anybody in algebra is going to use the same letters. M and B are going to represent the slope and the y-intercept. So your goal in order to graph using this form is to be able to identify the slope, identify the y-intercept, and then be able to graphically represent them. Okay, so now let's go ahead and actually do some graphs. So our first equation, what you're going to have to do is be able to identify what is the slope and what is the y-intercept given in an equation. So our first one, we have y equals 2x minus 4. So what I'm just going to ask you to do is compare it to what we had, y equals mx plus b. So the two things that I want to identify in this equation is what is m, what is my slope, and what is b, what are my y-intercepts. So it's pretty simple to visualize in some of these simple equations. If you remember last time or last video when we talked about slope, slope is always the number in front of x. So it's a pretty simple thing to visualize. Y equals 2x minus 4. Notice that m represents the number in front of x. So 2 right here is my slope. So I have a slope of 2. Now the way I always want you to visualize the slope is I want you to visualize it as a fraction. So 2 is going to be 2 over 1. Why do I want you to do that? Because remember, slope is rise over run. Most common mistake that I see when you have a whole number with students is they'll just simply say 2 and they'll go up 2, but they won't go to the right or left 1. Okay? They don't do the run when they see just a value of 2. So this one, I have my slope of 2 over 1, and then my y-intercept is, and I have to be careful here, I'm going to pay attention to the sign before, is going to be negative 4. So here's how I'm going to go ahead and graph this. I'm going to start with my y-intercept, my initial value. I'm going to start at negative 4. I know that that's my y-intercept, so that's the point where the line crosses the y-axis. The next thing I'm going to do is plot my slope. So remember, my slope represents 2 over 1. So from this point, I am then going to move up 2, and I'm going to move right 1. Remember that when we do this graphically, we always go from left to right. So starting from this point, I'm going to move now to the right and not backwards. Okay, so I'm going to go up 2 over 1. Which is going to be there. So I'm going to rise 2 over 1 again. I'm going to put as many points as I can in this space. So there I'm able to plot 5 points, and now I can see the general relationship shown here, and boom, I can graph the line. So again, we started with the y-intercept, and then plotted the slope, rise over run from left to right. Okay, so now let's take a look at the next one. So again, same thing. Let's identify what m and b are. So start with m. I know the slope is going to be the number in front of x, so I have negative 5 over 4, or negative 5 fourths. Now I kind of did it here. Anytime you see a negative slope, here's what you want to make sure you do. The question I always get is when I write negative 5 fourths, is the 5 negative, is the 4 negative, or both? Remember when we see this, we always apply the negative to the top number. Okay, we're always going to describe the numerator as being negative and never the denominator. So this represents negative 5 over 4. My y-intercept is going to be the plus 4. So my y-intercept is the number that follows. So again, to graph this, I'm going to start with my plus 4. I'm going to start with my y-intercept, which is right here. Then again, I'm going to move from left to right. I'm going to plot my slope. Now notice the slope is negative 5 over 4. So remember, negative 5 over 4, my rise is going to be negative 5, and my run is going to be 4. Now, what the heck does this mean? How do I have a rise of negative 5? How do I go up negative 5? Oh, that doesn't make sense. Maybe instead of rising, when I see negative, maybe that means I'm going to go down 5, and that's exactly what happens. What I'm going to do from this point is not move up 5, but I'm going to move down 5 and right 4. So So that's going to put me right here, and that's enough. That's the only number, I can only get those 2 points on this graph. But now I see I get a line that goes down and to the right. And if you remember from last video, we talk about how this is what's called a negative slope. And notice here how the number itself is negative. So again here, if you see this negative, you always apply to the top number. Bada bing, bada boom, you're done. Okay, now the next one, this is kind of tricky. Ooh, my x equals 4. Well, where the heck is my slope and my y-intercept? Interesting. What's my slope and what's my y-intercept? Well, okay, so notice that this one says, take it as literally says, it says that x equals 4. So x equals 4, that's this point right here. But now the question is, what is the slope and the y-intercept? Well, in this case, you should notice that you don't have the form y equals mx plus b. This is not the same form that you see up here. Okay, so what does this represent, x equals 4? What this is telling you is that when you see this x equals 4, it's saying that x is always going to equal 4. So no matter what y is, x is going to be 4. So in this case, we can't really get a slope and a y-intercept. So how do we draw this? Well, how do I draw something that represents x is always 4? Well, this is going to tell me, boom, that it's just going to be a vertical line through x equals 4. And if you remember this, just think about back to our idea of the x and y intercepts. This one only has an x-intercept. It doesn't have a y-intercept, so that means it doesn't cross the y-axis. In this case, it would be a vertical line. And if you remember, what's the slope of a vertical line? What did we say this would be? Remember, we called this slope as being undefined. Okay, so this doesn't have a positive slope or a negative slope, so it's undefined. Okay, so we have 3 more examples here. First one, y equals negative 1/4 x plus 3. Again, identify my slope. My slope is going to be negative 1/4, which I can then write as negative 1 over positive 4. My y-intercept is going to be 3. So graphing this, I'm going to start at plus 3 is my y-intercept. And then I'm going to move, now notice this one, 1 over 4. So my denominator is bigger. That's okay. This means I'm going to go down 1 and right 4. So I'm going to put a point here. Now the thing is that I want to point out in this example, excuse me, is do I always have to go from left to right? Well, yes, I want to go from left to right. But if you notice all the examples I'm doing, I'm only going on this half of the graph. So how would I plot points on the other half? If I went down and to the right, how would I draw the line to make it go in the opposite direction? Now I'm going to draw the line first. So notice here, boop, put the line between those 2 points, bada bing, bada boom. I'm good. Now, my line's not the best, so bear with me for a second. But if you want to graph points in the other direction, instead of going down 1, right 4, if I want to go in the opposite direction, I'm going to literally go opposite to what I just said. So instead of going down 1, I'm going to go up 1. And instead of going right 4, I'm going to go up 1 and left 4. Meaning I would have another point right here. Now as you can see, I didn't draw my line that good, didn't go through that point. But I can go the opposite direction as long as I apply my slope in the opposite direction. That might confuse you, so if it did, always know you are always going to go from left to right, but it is possible to graph in the opposite direction. Next one, my slope. Y-intercept, I have y equals 1/4 x. My slope, as you can see, is 1 over 4. But b, what the heck? There's no plus something. There's plus what over here? Well, it's not shown. Well, we would add what values then would not show? Well, that's got to be probably plus 0. So my y-intercept does not always have to be a number. Y-intercept could be 0. So in this case, my y-intercept is 0, means it crosses through the origin. So I have that. Then my slope is positive, so I'm going to go up 1, right 4. It's going to give me a point here. And again, to show you what I can do, the opposite direction, instead of going up 1, right 4 all the time, I can go opposite, down 1, left 4. But remember, it has to be opposite overall. If you look at this one, if I went down 1, left 4, notice how I get negative 1 divided by negative 4. Well, both of those would be positive, and it gets me the same slope. So notice how going in the opposite direction still counts as having the same slope. Next one, I get y equals 3 minus x. Now notice this equation, what's wrong with it? Well, in all these other equations, the x came first, and now the x is coming second. So last point I want to bring up here is always make sure it's written in the correct form. So we might have to reorder things. So I'm going to try and rewrite this equation with x coming first. Now when I do this, I notice that it's minus x. So I'm going to do negative x, and then I notice it's positive 3, so that's going to be plus 3. Make sure if you do that way, you got to recognize the signs in front. Now, recognizing the slope and the y-intercept, what's the number in front of x? Well, you look at this one, oh my gosh, you have a negative x. There's no number there. What do I do? Remember, negative x really represents that there's a 1 there. So this is negative 1x. So my slope is negative 1, which again is a whole number you want to put over 1. So always write it as a fraction, negative 1 over 1. And we're going to apply that negative to the top. And my y-intercept is obviously 3. So plotting this, I'm going to start at plus 3 as my y-intercept. And now my slope is negative 1 over 1. So that means I'm going to move down 1, right 1, down 1, right 1 throughout. So I can plot these points, down 1, right 1, here. And again, I'm going to plot as many points as I can fit. It's going to help me to draw this graph. If you're struggling with drawing the graphs, you can always, drawing the lines, you can always pull out a ruler or a straight edge if that makes you happy if you like the straight lines. Okay, so those were examples of graphing using slope-intercept form. Okay, now let's see if we can do the opposite. Now let's see if I give you a graph, can you identify what the slope and the y-intercept are and write the equation? So to do this, what we're going to do is, again, try and get our equation in y equals mx plus b form. The two things I need to identify here is what is my slope and what is my y-intercept. So from the graph, hopefully you're able to recognize these things. The y-intercept is the point where the line crosses the y-axis. So in this first example, I can see, oh, there's my y-intercept of negative 1. What's my slope? Well, from any 2 points, I can find the slope. So I'm going to choose my y-intercept. This one's going to go, let's see, down 1 and then right 3, looks like. Down 1, right 3. So down 1's going to be negative 1 over 3. So that's going to give me a slope of minus 1 over 3. And again, if you want to check that, it would be the same for all the other lines. So what's my equation? Y equals negative 1 over 3x minus 1. So all I'm going to do is just put my slope and y-intercept back into the equation where it went. So we're just doing the opposite here. Next one. My y-intercept I can see right here is at 1, 2, 3, 4, 5. So my y-intercept is at b equals 5. And my slope, what is my slope? Well, again, slope, rise over run. So starting from this point, well, my rise is 0. Over my run, well, I'll just say it's 1. It goes over 1 box. So what's the slope of 0 over 1? Well, that's slope of 0. So when I write this equation, it's y equals 0x plus 5. Well, 0x, anything I plug in for x is going to cancel, so that really drops out. And what I have, y equals 5. Very good. So notice this one, we had y equals 5. That represents here a horizontal line, something with 0 slope. All right, and then last example here. What is my y-intercept? Well, my y-intercept, it doesn't cross the y-axis, so there's none. Interesting. And then my slope, well, my slope, notice how it goes. What's my rise? It goes up 1, but then it goes right or left 0. Well, what the heck do we call it when we divide by 0? Oh, that's undefined. Okay, so how do we write this equation that's undefined? It's a vertical line. Well, if you look back to other examples, it doesn't have a y-intercept, slope's undefined, so I'm going to write this as x equals, and I'm just going to put the value of negative 4. Okay, so key thing here, notice that when a line is horizontal, we have y equals the value, saying y is always going to be 5. A vertical line has the form x equals negative 4. This is saying that x is always going to be equal to negative 4 no matter what y is. So two key things, is two kind of rule breakers, kind of tricks, is if you see horizontal versus vertical lines. All right, last two examples here. This one's going to apply some stuff we did last chapter, which a lot of you guys didn't like and struggled with. But what if I give you an equation that's not in slope-intercept form? So again, slope-intercept form is y equals mx plus b. So notice it starts as y equals. So what if I give you an equation that doesn't say y equals? Well, what do? Well, you're going to have to make it so that it says y equals, meaning you are going to have to solve for y. So we learned this skill last chapter, solving an equation for y. So hopefully this is a little review. So the first equation, I have 2y equals 6x minus 8. Y is not by itself. It has the 2 with it. So I got to get rid of this 2. So remember, in order to do that, I'm going to do an inverse operation. So in this case, I'm going to divide this side by 2 and take and divide everything over here by 2. And that's going to give me y equals 6 divided by 2. Well, I can't do that. Oh, no, yes, I can. 3x minus 8 divided by 2 is 4. Is this equation now in slope-intercept form? Ah, you betcha. Now I want to be able to graph this, so now I can recognize, hey, my slope is 3, which again is just equal to 3 over 1, and my y-intercept is negative 4. Make sure you pay attention to the sign. So I can graph this, start at negative 4 again, and now I'm going to go up 3 over 1. I'm going to go up 3 over 1, up 3 over 1, try and get as many points as I can, and then draw my line between those points. Ooh, that line was bad. I'm sorry about that. Now the next one, we have a little more challenging one. I have 4x minus 3y equals 9. So again, this one I want to write in slope-intercept form, so I got to solve for y. So my y is right here. So what I got to do? Well, I got the 4x and the 3 and the negative 3 there, so I'm going to get rid of both these. So I'm going to start by subtracting 4x. Now the biggest mistake a lot of you made or will make with this is, remember, you can't subtract 9 and 4x because they are not like terms. So this side cancels, but what do I do if I can't subtract them? Well, I'm going to leave them. Now, when you do this, I'm going to write it so that my x comes first. So I know that I'm just thinking ahead, have it in slope-intercept form. I know that the x term is always going to come first. Okay? So last thing here is I have negative 3y. Notice how I didn't forget about that negative sign in front of the 3. So I'm not just going to divide by 3, but I'm going to divide by negative 3 here, but boom. And I'm going to divide everything over here by negative 3. Now this looks sassy. But remember, think of the idea of slope. This is actually going to be nice when we think about it. So I'm going to get y equals negative 4 divided by negative 3. Well, I can't divide those, but I know that two negatives make a positive. So I'm going to get 4 over 3x minus 3. 9 divided by negative 3 is minus 3. There's my equation. Okay, this one, notice how fractions scare you, but now when we talk about the idea of slope, it's not that bad. 4 over 3. So that means I'm going to start at negative 3. I'm going to apply my slope, which is going to be up 4 over 3 right to there. And that's really the only 2 points I can get. So I'm going to draw then my line between those 2 points. Okay, so in this case, you're going to solve for y, be able to identify the slope and the y-intercept. Okay, so hopefully you got through these examples and you understand the things. Again, if you understand the idea of slope and your ideas of intercepts, this actually becomes relatively easy. Because again, this is going to be a skill you're going to need for the rest of the year. So good luck on the practice problem. Bring any questions to class. We'll see you guys later. Peace.